Hi everyone, this is Kruti Jai Pancholi, Assistant Professor in LJ Institute of Engineering and Technology in Department of Electronics and Communication. This video is about subject Analog and Digital Communication System. From this video, you will learn about bandwidth efficient amplitude modulations. Bandwidth efficient amplitude modulations. As we know that the frequency spectrum of the AM wave consists of carrier and two sidebands. So in that, as I said, the disadvantage is we need to transmit the more power, even though the cost of the system that can be also increased. So the modification in the AM system that is required. For that, the various kind of the modulation techniques are available. One is DSBSC. It's a double sideband suppressed carrier modulation. Another is SSBSC, single sideband suppressed carrier modulation. VSB, vestigial sideband modulation. Very first, about the double sideband suppressed carrier modulation. Now in this, we will discuss about DSBC modulation, the modulated wave that consists of the upper and lower sideband. As I said, upper and lower sideband consist of the same information. So now when we are transmitting the signal and if we are transmitting the copied information with both the upper and lower sideband, it's a wastage of power. So transmitted power we can save, okay, by suppressing the carrier wave, as well as we can the channel bandwidth requirement, okay, that we can also save. So the transmitted power that we want to save. Now as we know that the carrier does not have any information, so if we will suppress the carrier, then we can save the transmitted power. So same way in the SSBSC modulation. SSBSC means single sideband suppressed carrier, single sideband. Now LSB, USB contain same information. Then what we can do? We can also transmit the either of the sideband, so that what happen? We can save the bandwidth, we can save the transmitted power. So in the SSB modulated wave that consists of only the upper sideband or the lower sideband, SSBSC is suited for the transmission of the voice signals. It is an optimum form of modulation in that it requires the minimum transmission power and minimum channel bandwidth. Disadvantages: increased cost and the complexity. So now there should be some algorithm which can work for it, and so that we can also save the channel bandwidth. Next is VSB, vestigial sideband modulation. Particularly this vestigial transmission, vestigial sideband modulation, that is used for the transmission of the television signals. Now what is the meaning of this? In that the one sideband is completely passed and just a trace or vestige of the other sideband is retained. As we know that the LSB, USB that contains the same information. So what we can do? We can transmit the either of the sideband and we can take the few part of the other sideband, so that it is known as the vestigial sideband. Okay, so the required channel bandwidth is therefore in excess of the message bandwidth by an amount equal to the width of the vestigial sideband. This method is suitable for the transmission of the wideband signals. This is the diagram of the double sideband suppressed carrier modulation. This is the original spectrum of the signal. Now here you can see that the redundant bandwidth consumption in the DSB modulation. This is the spectrum, okay, double sideband. Now here the FC and the minus FC, that's a frequency, 2B is the bandwidth, and the USB and LSB are there. So in the double sideband suppressed carrier, now there is no carrier, only the two sidebands that we observe. This modulators that makes a use of the multiplying action, in which the modulating signal multiplies the carrier wave. Now carrier component that we have to eliminate, and upper and lower sidebands are transmitted. So as the carrier component is suppressed, the power required for the transmission, it is less than that of the AM. This is the carrier wave, amplitude is EC, it is the modulating signal, and this is the DSBSC waveform. If the empty message signal NCT is equal to AC cos 2 pi FC is the carrier signal, then DSBSC modulated wave is denoted by ST. ST is the carrier multiplied by MT. So carrier is AC cos 2 pi FCT into MT. So consequently, the modulated signal ST undergoes a phase reversal where the message signal MT crosses the 0. The envelope of a DSBSC modulated signal is therefore different from the message signal, and the Fourier transform of it is given by SF is equal to AC by 2 MF of F minus C plus MF plus FC. So this is the again the suppressed carrier modulation diagram. This is the original spectrum of the message. So in the frequency domain, it is represented by MF having the bandwidth minus W to W. These having the bandwidth is 2W. This is 2W, and this is the 1/2 AC M0. So here, as you have seen that the bandwidth is minus W to W. The spectrum you have seen that, and here the scaling factor you can multiply and you can change the transmission bandwidth. Again, it is the diagram of the SSB spectra for suppressing the one DSB sideband. This is the baseband signal. Now all of you aware about what is the baseband signal? So baseband signal is M of F, M of T, Fourier transform, okay. By converting that into the frequency domain, we can have the spectra of the signal. Again, it consists of both upper sideband and the lower sideband, okay. Now here, what we need to do, that we can multiply the cos omega ct, and what we can do, we can shift the spectrum, okay. So here also the spectrum that can be shifted. Over here again you can see that the other part that can be the shifted. And what we have the one component on both the side. So either the LSB or the USB can be suppressed from the DSB signal via band pass filtering, in which only one sideband is transmitted, which is known as the single sideband transmission. It requires only 1/2 the bandwidth of the DSB signal. So this way we can also do it for the SSB. So double sideband, single sideband and the VSB. So double sideband consists of two sideband, lower sideband and upper sideband. Double sideband suppressed carrier. So only the transmission of the two sideband and carrier is suppressed. Single sideband so contain either of the band, either the lower sideband or the upper sideband. Single sideband suppress carrier. In that either the LSB or the USB that we need to transmit. Single sideband suppressed carrier. Single sideband suppressed carrier means either transmission of the band, okay, and carrier that can be suppressed. And the vestigial sideband mean on either transmit the LSB or transmit the USB. Now while you are transmitting the USB, take the some part of the LSB for the transmission of the signal, so that we can save the bandwidth. And why the name is the vestigial? Because while you are transmitting the one full sideband, with that part of the other sideband that you are taking, so whatever the part that you are not taking, that is the wastage of the sideband. So that is why it is referred to as a vestigial sideband transmission. And in that vestigial sideband transmission, the channel bandwidth for the television signals that can be also reduced, okay. So for reduction of the channel bandwidth, the vestigial sideband that is considered to be as a good technique of the modulation.
So therefore in the radio communication, single sideband modulation or single sideband suppressed carrier modulation is that can be used for transmitting the information, such as audio signal, for transmitting the radio wave, as well as the various technique of the amplitude modulations that can be used for saving the transmitted power and as well as saving the bandwidth. So this way we can go for the other techniques in detail. So till right now we are ending with the session. Okay, so thank you very much everyone.